Okay, this video is about special right triangles. It's going to feel like we went back to geometry because we are going back to geometry a little bit. Before we can move on to trigonometry, you need to remember what special right triangles are and how you solve them. Okay, so there are two right triangles. There's the 45, 45, 90 and the 30, 60, 90 right triangles. So we'll do 45, 45, 90s first, okay? If you remember, a 45-degree angle, a 90-degree angle means the other angle is 45 also because angles add up to 180. Now, if you know one side and you know that the angle characteristics are these, you can find the other two sides. It's always going to follow a pattern. So here's how you do it. Okay, the pattern is this. Across from the 45 is the length of x. Across from 45 is the length of x. These are the same. And across from the 90-degree angle is whatever x is times the square root of 2. That is the pattern you need to know. So if I give you an example problem like this, across from the 45 degrees, you may know one side. In this case, it's a 6. And that gives you enough information to figure out the rest of the sides. So we know that if across from 45 is the length x and both sides are the same, then this is also a 6. It's an isosceles right triangle. Across from the 90 is whatever x is, which we know is 6 in this case, times the square root of 2. So 6 square roots of 2. So in your assignment today, you're going to see things like, what's the length of BC? Well, BC we said is 6. And what's the length of AC? Well, we figured out from our pattern that it's 6 square roots of 2. Okay? That's the basic idea. The pattern is the same. Now, if it's a 30, 60, right, 90 right triangle, the pattern is slightly different. It says this. It says x square roots of 3, 2 times x. So it's important that you know what side is across from each angle. So, given this example, look at the picture down here. 60 degrees is here. I don't know the side across from 60, and that means this angle is 30. I don't know the side across from 30. I have to figure that out. But what I do know is the side across from the 90-degree angle, and in this case, it's 18. Okay, so what do? Well, it's a little equation. 2x equals 18. Solve it, x is 9. Now I can fill in the gaps. So across from 30 is whatever x is. We just solved that that's 9. Whatever across from the 60 is that x value times the square root of 3. So again, on the work today, you'll see the missing sides. Wx we know is across from the 30-degree angle. So that is 9. And then yx is across from the 60-degree angle, and that is 9 square roots of 3. Okay? We're going to do more examples, but I wanted just to remind you of the patterns, and you need to write these down and use them a lot. Alright, so let's try another triangle. Notice the clues. You got a 30, 60, 90 right triangle, and look, they back up to one another, right? These are 30, 60, and 90 because this is an equilateral triangle. So hopefully that makes sense, what I did there. So if it's equilateral, I know that these sides are all the same, right? But what I don't know is what the length of HJ is. I don't know all these other lengths, okay? So let's solve this out. So across from, what I know is what the side across from the 90. That's the given side. So I'm going to put my pattern in. X square roots of 3, 2x. The side across from the 90 is a 10. So I solve it. So I can fill in the gaps. So this is 5 square roots of 3. Okay, so now I can look at my diagram. GJ is the side that's across from the 30-degree angle. Well, according to my chart, that is the length of 5. HJ is the side that's across from the 60-degree angle. According to my chart, that's 5 square roots of 3. GI is this whole side. Well, guess what? This is 5 and 5. Add them up, you get 10, which should make sense since it's an equilateral triangle. And then HI is this hypotenuse over here. And we said that this was the same as this side since they're equilateral. So this is also 10, right? Let's try another example. Here's a 45, 45, 90. How do I know this is a 45, 45, 90? Well, it's a square, right? All sides are equal. And if all sides are equal, that makes an isosceles right triangle, which makes each angle 45 degrees, right here. So I just happen to have two isosceles rights put together. The hypotenuse is a 20, and that's all I'm given, but I need to find the missing sides, okay? So the pattern for 45, 45, 90 is x, x, x squared roots of 2, right? So what do I do now? Well, what side do I have? I have the side across from the 90. Either way you look at it, it's the side across from 90. So I need to figure out, okay, x squared roots of 2 equals 20. How am I going to find x? Well, here's the basic idea. If this is what happens, you first are going to divide by 2, because that's what's under the radical, divide by 2, and then multiply that result by the radical of 2. Okay, so if I divide by 2, I get 10, and I multiply by the radical of 2. All right? So the two sides are the same, we already said that. So each side would be 10 square roots of 2. So ST is 10 square roots of 2. And the angle Y, well, we said it's 45 degrees because it was a square and it's made into two right triangles. We have a 30, 60, 90 right triangle. So our pattern across from 30 is x, across from 60 is x squared roots of 3, across from 90 is 2x. So you look at your problem and see what is given, okay? 18 is given, and what is it across from? It's across from the 60-degree angle, so it's going to go right here in my chart. I have to use this information to solve for x, which then I will multiply by 2 and get what's across from the 90. So how do you do this? Well, x squared roots of 3 equals 18. So the way you're going to solve this is very much like what we did with the 45, 45, 90. The first thing you're going to do is divide by 3. Why 3? Because that is what's under the radical. And then the second thing I'm going to do is multiply by the square root of 3. I'm going to put the radical back in my answer, but first I divide it by 3, then I multiply by the radical 3. This will give me my x. So 18 divided by 3 is 6. Then I multiply by the square root of 3, so 6 square roots of 3. Now for the 90-degree angle, I have to do 2 times 6 square roots of 3. All right? When you multiply radicals, you multiply whole numbers by whole numbers and radicals with radicals. So in this situation, I just have 2 times 6, which is 12 square roots of 3. And that's how I would leave my answer. So my answer is DE is the side across from 30. Well, we found that to be 6 square roots of 3. And then DF is the side across from the 90-degree angle, and that is 12 square roots of 3. All right? Now, just a little side note, adding radicals, all right? When you add radicals, you can only add them if what's under the radical is identical, all right? So in this example, both have the square root of 2, so it's fine. But you only add up what's on the outside. So 3 plus 5 is 8. Square roots of 2 would be your answer. Leave the radical like it is. Treat it almost like a variable. Same thing on example 5. Since the radicals are the same, I leave the square root of 3 and I add them up. I got 10 and I have 3. Add 10 plus 3, you get 13. So when you add radicals, which you will see on the worksheet today, you need to remember these properties, okay? Don't do anything with the radical. Leave it alone and just add the outside numbers. But you can only add them up if what's under the radical is identical. All right? Good luck, and we'll see you in class.